This is a production of Cornell University.
All right, so let's start on soil organic matter. Okay, now, there are basically three sets of lectures that I have during the semester that I think are the most important. One of them is texture and mineralogy. One of them is this one, organic matter, and the last one is pH. Now, you guys remember me saying in the beginning of the semester, maybe I don't know, maybe I didn't actually say this, but of the three most important things to know about your soil, and it will give you an idea about everything else that's going on in your soil. The three are texture mineralogy, organic matter, and pH. Okay? If you think about all of the stuff, all of the implications of your soils, those three are the most important. And I say that because I put this slide up here, not with the expectation that you guys are going to be able to see it up here. It's in your book. But this slide represents all of the effects that organic matter has in the soil. Okay? Any kind of material that's organic that gets into your soils basically has a number of effects. There's three primary effects with all of these basically spinning off of it. The first of those primary effects is if added to soil, it protects the soil surface from soil energy and raindrops. Basically, it helps climate control. Secondary effect. Coarse organic particles basically help structure and texture of the soils. Not texture, creates the structure of the soil, which means it helps with water infiltration and water storage. Third one is basically it acts as a food source. It is a nutrient source for your soils. So, climate control, water control, and nutrients control. Now, if you guys can think of a number, there are plenty of other things that go on in the soil. But from most management perspectives, what are the biggest things that you're concerned about? Climate control, water, and nutrients. Okay, that's why this is important. That's why these three lectures are so important, because each one of those basically helps control each one of these things. Okay, so if we're going to talk about organic matter, we should just basically get a big overview, a general overview of the global carbon cycle. We're going to be talking about this pool, but each one of these boxes basically represents a pool of carbon, with the arrows being the fluxes, the exchange of carbon between those pools. Okay? The largest pool is basically the carbonatic rocks, or the sediment that's basically in the planet. Okay? From there, you're basically looking at the oceans. Okay? The next largest pool is fossil fuel type of material. The next is soil. It is a large component of this cycle. Now, there's a couple other pools here, the atmospheric and the vegetation. Those are fairly large pools. The interesting thing is if you look at where the fluxes are, most of the fluxes are actually between these pools up here. So that's where most of the global change of the cycle is. Okay, yes, there is some exchange between the ocean and the atmosphere, but a lot of that flux is happening up here. Okay, we're going to be talking about this pool for the next three lectures. Okay, so what is organic matter? Well, you all probably heard, 99% of our bodies, 98% of our bodies is water. Well, we're going to be talking more about organic material associated with plants, okay? But it's still a fairly large percentage of that organism, or that material. 75% of it is water, okay? 25% of that we consider dry matter, okay? That dry matter is broken up into a lot of different components, and we're going to be talking about some of those actually, we're going to be talking about all these components over the next couple of days. The other interesting thing is if you think about these components, the building blocks of these components are predominantly carbon and oxygen, hydrogen, and then a lot of other stuff. That's that ash. Okay, nitrogen, for example. Soil organic matter in mineral soils, and these are not organic soils, in mineral soils, soil organic matter is generally between 2 and 5%, okay, by weight. And it does depend upon the management. The more our agricultural practices, the more disturbance that you put in the soil, generally the lower that number is, okay? But that's not always the case. And generally, the least disturbance, the less disturbance you do to it, the more organic matter you have in it. But again, that's not always the case, okay? The organic matter profoundly is affected by the soil properties, what is going on in the soil, and also how we're managing it. Its elemental composition, as I just said, is basically carbon, hydrogen, and oxygen, but it has a number of other ash contents in them. Okay. It is the main source of nitrogen and sulfur for plants. Actually, it's the main source for all of the nutrients for plants. Okay, in unfertilized soils. And its form of organic matter, and this is important, the forms of this organic matter are living and dead plant materials, the organisms, basically living, as well as humic materials. Okay, now, keep in mind these three components. Okay, because part of the lecture today is actually going to be challenging or changing or maybe introducing some new concepts. We're changing the paradigm of soil organic matter has changed dramatically in the last 5 years. So when I gave this lecture, when I started giving this type of lecture 9 years ago, the lecture that I gave is very different than it is today. Now, why are we talking about it again? This is why. All right, to give you an overview of where the organic matter is in the soils, these are the soils, the 12 soil orders, as well as miscellaneous lands. Okay, if you think about the amount of organic carbon, do you guys remember me talking earlier about, I showed a table, I think I showed you guys this table, something similar to this, and I basically said, this is the distribution of orders across the world. And I took a look at the United States and I said, this is the reason why the United States is the breadbasket to the world, because we had a predominant large amount of mollisols and alpha soils. Okay, well, take a look at this in the same, sort of the same lens. Okay, if we look at all of these soils and we look at the organic carbon that's in them, okay, here's histosols, those organic soils, which makes sense that they have a huge amount of carbon per acre or hectare in this case. But if you look at the global total, it's not, I mean, it's still fairly large, but it's not as large as this number is compared to the others. Okay, the reality is, yes, there's a lot of organic matter in histosols, but there's not actually a lot of histosols. But when you do have a histosol, it's got a lot of stuff in it. So it's sort of a circular type of discussion there. But, okay, the other thing that I want you guys to look at is I want you to look at these mollisols. Okay, these mollisols have a fairly low number. Mollisols and alpha sols right here. These two numbers right here, okay? Look at the amount of organic carbon that's in those soils, okay? Yet, those are these really fertile soils, okay? So the take-home message is just because you have a lot of organic matter doesn't necessarily mean it's bad. Just because you have a low amount of organic matter doesn't necessarily mean it's bad. It's the form of that organic matter and how you manage it, okay? So if these two soils, these mollisols and alpha soils, have fairly low organic matter compared to the histosols, and if you look at the global composition of it, we're still talking about really fertile soils, even though they have a relatively lower organic carbon than the histosols.
This has been a production of Cornell University, on the web at cornell.edu.